start with the new thing today. In this, I have not written any question. I have written just a polynomial, that is 2x square minus 3x plus 1. So what the question would be, suppose we have to find out the value of the polynomial. So the question would be find the value. Find the value of polynomial. So how to find the value? So they must be given into the question if the value of x is 0, if the value of x is 1, if the value of x is minus 1. Like thus you have to substitute the values of x 0, 1, minus 1, 1 after 1, and you have to obtain the value of it. Let us first we substitute x is 0. So in this question, the polynomial, wherever the x is there, we have to substitute 0 for the same. So whenever we substitute x as 0, so you can see x square at 0, 3x 0. So 0 multiply with any number 0 with 0 plus 1. So the answer comes 1. We should remember one thing, whenever the value of x is 0, our answer is always a constant number. So we can say when the x is 0, the value of polynomial, this polynomial is 1. Let us do the same way. Let us substitute x is 1. So wherever the x is there, we will substitute x is 1 into the question. X square x 1, 1. So first we give the power 2 into 1 minus 3 ones are 1 plus 1. So 2 ones are 1 plus 1. So that is 3. And 3 minus 3, that is 0. So here you can see that the value of the polynomial is 0. So we should remember one thing, whenever you obtain the value of the polynomial 0 after substituting the certain value of x, हमने x की value 1 रखा तो हमें polynomial का answer 0 मिला. So we can say that this value of 1 is zeros of the polynomial. So here we understand whenever we substitute certain value of x and we will obtain 0 as an answer, so we can say that that value of x is called zeros of the polynomial. Let us see the first question of exercise 2.1. It is like the same that previous example we have seen. We have to find the value of the polynomial 5x minus 4x square plus 3 when the value of x is minus 1 and x of value is 2. So let us do this first. We will substitute the value of x is minus 1 in the given polynomial. So wherever the x is there, we will substitute minus 1 for the same. Jahan bhi x hai, we have to just substitute minus 1. So 5 ones are 5 plus minus minus. This sign as it is, first we have to remove the power, give the power. So square of minus 1 is always plus 1. Now minus 5 minus 4 plus 3. This both are the equal signs, so it must be addition, and the answer is minus 6. So the value of this polynomial when the x is minus 1 is minus 6. Let us do the same way. Substitute the value of x as 2 in this polynomial. So p of 2 is equals to 5 into 2 minus 4 into 2 the square plus 3. I have substituted the value of x as 2. So 5 2s are 10. Minus 4, 2 2s are 4, plus 3. We can do the sum of these two as this both are positive. So 13 minus 4 4s are 16. So the answer comes minus 3. Thus we can find out the values of the polynomial when the values of x are given. Let's see again, it is almost the same kind of question, but it is asked in the different frame of the question. We have to find out the value of p of 0, p of 1 and p of 2. For the given polynomials. So in the first question they have given the polynomial y square minus y plus 1. For this we have to find out three values. We will substitute y0, y1 and y2. So let us substitute. See, this question is the same that which we have done the previous one. So let us first to find out p of 0. That means the value of y we have to substitute 0. So y की जगह हम 0 रखेंगे. So whenever we substitute 0, so 0 0 0. So we obtain the answer 1. Now let us substitute y as 1. So wherever the y is there, we have to substitute 1. Square of 1 is 1. It's minus 1 plus 1. Plus minus cancel. So the answer is 1. Let's go for one more. we have to find out P of 2. So again in this variable we have to substitute the value of y, that is 2. The square of 2 is 4, minus 2 plus 1. We'll do the sum of first two positive number, or we can say the equal sign. 4 plus 1, 5, 5 minus 2, that is 3. Thus we obtain the value of all these three, P of 0, P of 1 and P of 2. Let us see one more question. Here the polynomial is given in the product form, x minus 1, x plus 1. So you can multiply also, but keep it as it is. Why we need to multiply? So let us substitute. Let us find out first P of 0. So wherever the x, we will substitute 0 for the same. 0 minus 1 is minus 1 and 0 plus 1 is plus 1. Again the product, 1 ones are 1. So the answer is minus 1. Let us find out P of 1. So wherever the x is there, we will substitute x as 1. So 1 minus 1, that is 0. 1 plus 1, that is 2. 0 into 2 is 0. Let's have one more value we have to find out, that is P of 2. So we have to substitute x as 2 in the given polynomial. So it is 2 minus 1 and 2 plus 1. 2 minus 1, that is 1, and 2 plus 1, that is 3, and 3 ones are 3. Thus we obtain the three values of polynomial for P of 0, P of 1 and P of 2. Let us see the third number of exercise 2.2. It is given whether we have to verify whether the following are the zeros of the polynomial with the values against indicator them. It is the polynomial given. It's a linear polynomial. The value of x is minus 1 by 3. We have to find out whether this value is the zeros of the polynomial. Remember, this term is going to be used in the 9th standard as well as in the 10th standard. The word zeros. Let us understand again what are the zeros, as we already discussed earlier. Zeros are such values of x. When we substitute those values into the polynomial, we will obtain answer 0. मतलब x की वैल्यू जब यहाँ पे हम सब्सटीट्यूट करेंगे, अगर मेरा आंसर 0 आ रहा है, so that value of x is considered as the zeros of the polynomial, which is not compulsory that value which is given of x is always obtain 0 as an answer. ठीक है, अगर हमारा आंसर 0 आ रहा है तो उसको zeros बोलेंगे polynomial का. Answer 0, so that value is called zeros of the polynomial. So again you can see that this formula or the method is not the different than which we have in the previous two. Let us substitute the value of x is minus 1 by 3. This is the value which is already given into the question. So instead of x, the value is minus 1 by 3. So we know these two are in the product, we can do the cancel, 3 cancel. So what remains? Minus 1 plus 1. So you can see that the answer is 0. As we obtain 0 as answer, we can say yes, x is equals to minus 1 by 3 is considered as zeros of the polynomial. Let us see one more questions to identify the same. Here in the second question, the polynomial is given phi x minus pi. We know pi is an irrational number. And the value of x is 4 upon 5. So let us substitute the value of x as 4 upon 5 into the given polynomial. 5 into 4 upon 5 minus 5. What I have done? I have taken the value of x as 4 by 5 and I have substituted in the given polynomial. Again it is a linear. Again this 5 cancel, we got 4 minus 5, which is not equals to 0. So we can say that the value of x 4 upon 5 is not considered as zeros of the given polynomial. Let us continue with the further sums. In the polynomial it is given Lx plus m and the value of x is minus m upon L. So let us substitute the value of x is minus m upon L into the given polynomial. L into minus m upon L plus m. You can see that this both the values of L cancel, minus m plus m. So the answer is 0. So our answer, we can say yes, minus m upon L is the zeros of the given polynomial. Let's have one more question. We'll go further for the question number 7. This is good number, quite interesting. Here in this question, the polynomial is given 3x square minus 1. and the values of x they have given is minus 1 upon root 3 and another value is 2 by root 3. So let us substitute both the values one by one to obtain whether it is zeros or not. So let us substitute the value of x is minus 1 upon root 3. As it is x square, so minus 1 upon root 3, x square minus 1 square. So we know first we have to apply the power. As we will apply the power, that is square, the negative term become positive. So square of minus 1 and square of root 3 is 3. So we can see that both will be cancelled, 1 minus 1, so it is 0. Let us do the same way. Let us apply or simplify this. For value x is 2 upon root 3. Let us substitute the value of x is 2 upon root 3 in the given polynomial. 2 upon root 3 the whole square minus 1. So I will substitute the value of, I have substituted the value of x in the given polynomial. First we have to apply the power. So 2 to the 4 and the square of root 3 is 3. So this both will be cancelled. So that is 4 minus 1. So it is 3. So for this, as we obtain 0, we can say yes, the value of x is minus 1 upon root 3 is the zeros. But for this, we will obtain 3. So we can consider no for this value of x, that is 2 by root 3. Let us see, this is the last question of this exercise and it is very important. It is written that we have to find out the zeros of the following polynomial. See, when you correlate this question with the first, second and third, so all are the questions that interrelate with each other. So again, here we have to find out the values of x. Which kind of values of x which satisfy the equations, or we can say the polynomial. पहले क्वेश्चंस में x के वैल्यूज रख के हमें वैल्यूज ढूंढने थे polynomial. In the second question, the values of the polynomial we have to find out. They have given p0, p1, p2. In the third previous questions, we have to find out whether the given values of x are zeros or not. तो हमें पता है जब values of x substitute will obtain 0 as a answer, तो वो values of x zeros कहलाते हैं. In this question, we have to find out the zeros. अब इसको हम previous questions से थोड़ा correlate करेंगे. When we can consider that the given values of x is the zeros of the polynomial, अगर हम x की values रखेंगे और 0 आएगा तब, तो हम थोड़ा reverse order में जाते हैं. एक example से हम समझ लेते हैं कि अगर p of -5 यहाँ पे रखेंगे in this equation, so let us see -5 plus 5, so we can consider zeros. ठीक है, तो हम बताएंगे x is -5 is the zeros of this polynomial. मतलब x -5 रखने से हमारा आंसर क्या आना चाहिए, वैल्यू ऑफ पोलिनोमियल 0. हम रिवर्स ऑर्डर में जाते हैं. टू फाइंड आउट द जीरोस हम वैल्यू ऑफ पोलिनोमियल जीरोस रखेंगे. मतलब हम p of x को 0 सपोज करेंगे. सो व्हेन वी सपोज दिस वैल्यू एज 0, so now you can see that this is the linear equation in one variable which you discussed in the last year, standard 8. Value of x we have to find out. अब 5 सामने जाएगा, so we can say that -5 is equals to x. So here we can say that x is -5 zeros of this polynomial जो हमने पहले ही ढूंढ लिया था. So thus for the linear polynomial it is quite easy to obtain the zeros of the polynomial. एक और सम करते हैं. Let us see one more question to find out the zeros of this polynomial. Here it is given p of x is 3x minus 2. Again to find out the zeros of the polynomial, हम p of x को हमेशा 0 ले लेंगे. So now let us substitute this value as 0. So we can say 3x minus 2 is 0. To obtain the value of x, first we'll take minus 2 to the left hand side. So that become plus 2. Now to find out the value of x, we have to take this 3 to the left hand side. And we know 3 is in the product with x. 3 का x के साथ relation क्या है, multiply. तो वो सामने आएगा तो that becomes in the division. So this is the value of x. This is called the zeros of this polynomial. अगर x की वैल्यू 2/3 हम यहाँ पे रखेंगे, let's do the verification. जरूरी नहीं है करना. To show you this, हम वेरीफाई कर रहे हैं. x की जगह क्या रखा है, 2/3. तो let us substitute x is 2/3. 3 3 cut, 2 minus 2 0. So we obtain the correct value. मतलब x की वैल्यू ये रखने से we'll obtain 0 as an answer. So this value of x is considered as zeros of the polynomial. Let's do one more question. Polynomial p of x is given 3x. So again we'll consider p of x as 0. So here we'll obtain 0 is equals to 3x. I'll take 3 left hand side. So it comes in the denominator of 0. If denominator of 0 any number, the answer is always 0. So we can say that for this particular polynomial, the value of x is called 0. It's the zeros of the polynomial. I hope you are getting all the sums. Let's do the last sum. Here in this, the polynomial is given cx plus d. It is cx plus d. Again, to find out the zeros for this, let us consider p of x as 0. So 0 is equals to cx plus d. You can correlate this with this question. We are going to do the same method. First we'll take d to the left hand side. So it comes in the negative. 0 minus d is cx. So minus d is equals to cx. Now I'll take c left hand side. So it comes minus d upon c. C comes in the denominator. The reason c is in the product with x. So thus the value of x we obtain minus d upon c. Thus this question is very important. Thank you.